Yes, now I am going to talk about the continuation of the discussion of the classical free electron theory. So last time we saw that in the classical free electron theory it is assumed that the free electrons are responsible for the conductivity. Now if you look at the movement of the free electrons will be moving in the lattice of the metal in a random zigzag movement like shown here. Like it is going from point A to point B, but outwards because of collision it changes its path. So like this it will go on changing its path, and therefore it will have a very zigzag movement. Now we can use some terms for this zigzag movement. One is the mean collision time tau and another is mean free path. Here if you look at the random movement, the time interval between two successive collisions, if we take the average of the time interval between the collisions, that is called as the mean collision time, we represented by the symbol tau. And similarly, if we take the distance traveled between two successive collisions and take the average of that is called as the mean free path lambda. Now we see that the electron is moving with the thermal velocity. Therefore we can write the thermal velocity is equal to mean free path lambda divided by mean collision time tau. We can see here that the thermal velocity, the value of thermal velocity in a metal comes in the order of 10 power 6 meter per second. It's a very high velocity, but in spite of that it produces no current in the wire. The current is zero. This is because of the random zigzag movement of the electrons. Now you know that the electrons will start moving in a one direction, and that is possible in the presence of an applied electric field, and that is when we get the drift velocity Vd. Now if you look at the drift velocity, it is proportional to the applied field. The more is the applied field, the more will be the drift velocity. And we see here we get the relation for drift velocity is equal to E, the charge of the electron, electric field applied, and the mean collision time tau, and the mass of the electron m, E tau by m. We can also see here if we remove the proportionality we get a constant. Then we get Vd is equal to the constant we represent it as mu into E applied. Here mu is known as the mobility of the free electron. So therefore you can write mu is equal to drift velocity by the applied field, and using this relation we get the mobility of free electron is given by E tau by m. We have to note here that the drift velocity value comes in the order of few millimeter per second. It's a less velocity, but even then this small velocity is responsible for the current flowing through the metal wire. Now if we look at the expression for the current density and the conductivity and the resistivity. For this let us start with the expression for current density J. We know that the current density J is given by Ne into Vd, where N represents the number of free electrons available in per unit volume in the metal, and E is the charge of the electron, and Vd is the drift velocity. Earlier we have got drift velocity is equal to E tau by m. So let us substitute this term here in this equation. So therefore we get Ne into E tau by m. So that means we can write it like this: J is equal to this term Ne square tau by m into E. But we know that J is equal to sigma times electric field. That means this bracket term is nothing but the conductivity. Therefore we can write conductivity sigma is equal to Ne square tau by m, or resistivity is reciprocal of conductivity. Therefore we can write it as m by Ne square tau.